Hi, everyone. Okay. Okay. Get me loud and clear, I think so. Let me see what's the status on LinkedIn. Okay. Hello, everyone. Good evening, good afternoon, good night, wherever you are. So this side Anand Jha here, coming up with a very exciting topic today, which is none other than Schema Evolution and Snowflake, one of the hot favorite buzzing topic, which I wanted to actually do it pretty far when I started this playlist actually. But fine that we are doing it today. Let's see. The way I'm going to teach you, it's completely out of the box, which you have never seen before anywhere present on the YouTube. Right. So let's wait for some time and then we'll get kick started. You see. Okay. Everything is uploaded. One second. Okay, let's get started. Good evening, everyone. Good afternoon, good morning, good night, wherever you are. This is Anand Jha here, founder and CEO of Analytics with Anand. So those who don't know me, I come here and teach data analytics, data engineering, and all this generative AI concept whenever I get time. So if you have not subscribed to Analytics with Anand channel, go ahead and subscribe it all. And wishing you a very, very happy Navratri on the this function of Navratri. Analytics with Anand is offering you flat rent 10% off on all the courses which you can go and enroll in all the data analytics, data engineering, and any AI related courses also. So if you have not still delved down into the data analytics world, this is the time. Go ahead and enroll in any of these courses if you belong from any of the background, because you get paid really, really well. Repeatedly, I'm telling you from the beginning since I have launched this my Analytics with Anand YouTube channel. And thanks, immense thanks to each one of you for making it a grand 30,000 family we have reached so far, 30,000. So warm welcome to all of you. Now this is in continuation with our Master Blaster SQL concept on Snowflake in the playlist which we have created already. So far 45 lecture has been done. So if you want to master SQL in the current era, you need to master Snowflake. It's a must. It's mandatory. You cannot skip Snowflake in the current era. So wherever course, if you are doing it, if they're not teaching you Snowflake, ask them to teach Snowflake, because that is very, very important for you all. And here, if you want to start your data analytics journey, start from the Snowflake SQL from lecture number 1. Playlist description already I have given in the link of this video. So go ahead and check it out. So this is the lecture number 46, one of the hot favorite topic which is widely used in the analytics industry, which we're going to cover is your schema evolution. Prior to that, let me share my screen quickly and then we'll get from there. Okay. Yes. So these are all the courses which you are seeing it 10%, 10%, 10%. Everywhere you will see all these 10% off. So anywhere, if you want to learn Python, statistics, ETL, data science, data engineering, anything, you just go ahead and grab this offer is valid just for next 2 days. That's what I'm telling you, right? The best part of the course is go ahead and enroll in this job guarantee program. Apply this coupon code here directly and then you'll get this kick started. Because again, from your 2nd October onwards, 3rd October onwards, again the price will go back again to 42,000. And what's stopping you guys? If I'm teaching you, getting you placed, refunding your money back, what else is stopping you? Just all you have to do is study, study, study. That's all I want, right? So this is the job guarantee program. Then we are launching the statistics from this Saturday onwards, from 4th October onwards. So you can go ahead and enroll in this course also. Here also same 10% offer is there. So if you apply, this comes to that 3,600. And all these, whatever I teach, everything is live at Analytics with Anand, right? So that's all about Analytics Anand. Go ahead and subscribe to this channel, Analytics with Anand, if you have not done so. Let's come back to the today's agenda. So today's agenda is all about schema evolution in Snowflake. Prior to starting of that, I have given, those who does not know me, go to my Anand Jha 90 on the GitHub, go to the repository, click on the Analytics with Anand repository and change the branch, right? Majority of you will comment in the chat, change the branch, make the branch to Snowflake. Make the branch to Snowflake and go to today's lecture. Today's lecture is lecture number 46, schema evolution. Entire data sets, entire code file, entire document, even the policies, everything has been shared with you. Everything. So you did not have to comment where is the data sets, where is this, where is that, so on. Okay, right. Let's get this started. So I'll open the documentation quickly. Get started, schema evolution, and here you go. Okay. So here, why schema evolution? What is the beauty of schema evolution and why I should cater, why I should think of schema evolution in Snowflake? That's the most important question. First of all, you should ask, Anand, why we are studying this concept? What is the beauty of this concept and what we're going to learn out of it, right? What exactly is? So as the documentation says, in today's digital world, data is like a water. It keeps flowing, but it rarely stays the same. Suppose 1 week your customer file may have 10 fields. Suppose your customer is sending every weekly data, right? And data, sometimes the customer or your client send you some 10 fields, some 10 attributes, then later he or she adds some 5 attributes, later next week he or she drops some 5 or 10 attributes. Then how your entire pipeline, which you're gonna design with the help of any ETL tool or in Snowflake, will work, right? Suppose you are working in a very quite agile methodology, which we say, right? Then in their concept, the schema evolution will come. Suppose 1 week your customer files have 10 fields. Next week, the business team quickly adds a new field called discount. A month later, compliance asks you to remove phone number. Do you think, is it manually possible for a developer to go back to the pipeline and change every time? Go back and write create table command and then add alter table and all those things? No, it's not physically possible. And if such things happen very frequently, your pipeline will break if it has not consumed the concept of schema evolution. That's where schema evolution comes into picture. Let's come back again. If you have not understood, one more example. Imagine you run an online shopping company. Every day your customer places orders, make payments and return items. All of this data is collected and stored in file like spreadsheets or CSV. Now here is the challenge. What is the challenge? Your data structure is not fixed. This week your sales file has 10 columns. Say order ID, date, customer, amount, etc. Next week again your IT team adds a new column called discount. Again a month later, finance team removes customer phone number because of privacy concern. How many times imagine you have to do all those changes, right? But if you work on the concept of schema evolution, which I'm going to make you master after today's session, which you have never seen in entire YouTube, right? Everything which I teach here at Analytics with Anand is in depth. Whatever I have learned, it's not a copy paste from anywhere. Okay, so if your data pipeline, the system that loads files in your database, expect exactly 10 column, it will break when file changes. That's bad for business. That's really, really bad for business, right? This is where schema evolution comes in handy. So schema evolution is the ability of your system to adapt automatically when the structure of incoming data column changes. That is when new columns are added or old ones are missing in incoming data files. When the schema evolution will come into the picture, when the structure of incoming data column, if it is coming from AWS S3 bucket, it is coming from Azure Blob, or if it is coming from Google Cloud Container, right? Your system should adapt automatically when the structure of incoming data column changes. That is when new columns are added or old one are missing in incoming data file. Then the concept of schema evolution will come. Now you will not implement schema evolution if the client is rigid. That means if the data is not changing, we gonna not implement schema evolution. Just the way you are designing your pipeline, it has to be. So the first question which you should ask to a business consultant, to a data architect, to a client, whomsoever you is talking, are we implementing schema evolution? Is there any change in the incoming data? Will the data change every month or every 2 months or 3 months? If the answer is no, you will not implement schema evolution, right? Do not apply your brain here. And the requirement, each and every requirement will come from the client hand side. Another real world case. Example, a credit card company. A bank wants to analyze how customer uses their credit card. They receive daily transaction files from different branches. How many people are doing Google Pay, Phone Pay, Paytm, Zomato, Swiggy, Zepto, Blinkit? Every day we do a lot of transaction. So imagine initially the file contained customer ID, balance, purchase and payment. Later a new column got added. Right? Later a new column got added. Say for example credit limit. A few months later, regulatory rules requires adding country and age. A few months later, regulatory rules require adding country and age. Sometimes a branch may forget to set certain fields like minimum payment. So without schema evolution, what gonna happen? Every time column change, developer would need to manually update database tables and pipeline. And this is very, very time consuming. This is a pain in the ass, right? This slows down analysis and frustrate business teams who need reports. With schema evolution, the system auto detect. You don't have to do anything. Once you have created your pipeline, once you have implemented this, entirely everything will be taken care automatically. Let the client push the data sets. Okay, be it 5 column, 10 column, 20 column, right? Automatically it will get evolved. Now there is one question which might come into your mind. Sir, what will happen? Say for example, if I drop column, what will happen to that data type? Or if I'm adding any new column, previously those columns were not present. So what will be the value in that column? Everyone knows the concept of left join. If there is no matching records, what the values gets in the left join? Null. So if any new values, right, new columns like credit line are added to the database automatically, missing columns are stored as null values empty. Okay. If you are adding any new columns, if you are deleting any new columns, whatever the columns were there, that will continue to work even when file keep changing. Only the data will be null if you are adding any new column, because prior to that, that column was not present. So if you are appending that column, so the value will be null over there. Got it? So this is the picture of schema evolution. Why is it important in IT industry? Right? So this is widely used in industry where data formats are dynamic. Highly used in healthcare, I would say. Healthcare, it has a very, very great use case. Apollo, Procto, every day. Say for example, a patient is admitted in a hospital. Next day, some another treatment, right? BP is high, blood level, sugar goes down, etc., etc., right? So new records are being added. Patient records evolve as new medical parameters are introduced. So schema evolution ensures historical data remains intact while supporting new tests. Right? Then your e-commerce. Say for example, product data changes constantly. Recently, you have this big billion day. Right? New attributes like color, material, warranty appears while others are removed. Schema evolution helps pipeline handle this gracefully. Another one, banking and finance. Customer data, transaction logs, and compliance fields evolve as the regulation changes. GDPR. Schema evolution ensures pipeline don't break when there's any change in the data. When there is any change in the attributes, any column gets added, any column gets removed. Right? Telecom, call records and recharge files evolve with new services. Schema evolution support, scalable ingestion without writing ETL jobs daily. You don't have to upload any pipeline. Once you have incorporated this concept, your pipeline will automatically ingest the new data with the new column or the deleted column, whatever you want to do. What is the business benefit? There are plenty of business benefit. It has a reduced downtime. Pipelines don't break when fixed file changes. Faster time to insight. No waiting for developer to fix the schema. Directly you can connect your Snowflake to the Power BI and you can have the insights ready if you have implemented schedule refresh. Future-proof pipeline. Scalable for hundreds of evolving columns. Add 200 columns, add 100 columns. You do not have to worry. Right? Cost savings, fewer manual interventions. Manual intervention is very, very less. After this today's session, you don't have to do chat GPT. You don't have to refer any Stack Overflow. You don't have to refer any code. Everything has been given to you. Entire documentation I have given to you. Save your time. Just do it, implement it, and write it in your resume so that you can tell to your client or stakeholder. Even the fresher, it's a boon project for the freshers. Okay? Analogy for the non-technical people. Right, most of my job guarantee program contains non-technical people. How you will explain? Suppose you are interviewing or you are getting interviewed. You are not interviewing. You are getting interviewed by a director and he or she wants you to explain in a very layman language. So imagine a schema evolution like your kitchen pantry. 1 week you store rice, sugar and salt. Next week you add pasta. A month later you remove sugar because of health reasons. If your pantry is rigid and only allows the original 3 items, you will struggle. But what if it is flexible? It automatically makes space for new items and adjust when something is missing. This is what schema evolution does for data pipeline. Right? So what does Snowflake means by schema evolution? In the context of Snowflake, what does it mean? So Snowflake can adapt a target table structure automatically. Basically, you are altering the structure. The Snowflake will adapt target table structure automatically. Whenever we are adding column or we are deleting column, guys, what we are doing it from the SQL point of view, you are doing alter table. Alter table, table name, add column, column name with the data type. That's what you are doing. This is what happening here at the backend side. So if you are going in the interview and if they are asking you what is happening backend, at the backend, alter table is running, which you are not running it. Snowflake internally does it. Right? Correct? Alter table, and whichever table you want to set schema evolution, just 2 commands you have to write. The first command, alter table, table name, set enable schema evolution equals to true. By default it is false because we don't implement it. So anytime if you want to enable schema evolution, you need to set it true. Now, when you will be ingesting data from external stage, lecture number 34 and 39, those who have not viewed my lecture number 34 and 39, go through that. How you will ingest continuous data ingestion from AWS S3, that I have explained clearly. Okay, how do you handle? With respect to Azure also I have explained lecture number 39, with respect to lecture number 35 with respect to Azure, and with respect to AWS, how you can have a continuous data load is lecture number 34. So copy into table, and here we will specify match by column name. Match by column name. If the column name gets changed, right, then it will have a new column. So match, here we are doing matching by column name, and we are making it case insensitive. So that if you are writing age, AGE, A capital, GE small, and then age capital, or age, G capital, all are age only, all are attributes only, right? So there will make case insensitive equals to true. Right? So 2 things. Whenever you are doing copy into table, the final when you are ingesting the data, there you will do match by column name. And then when you are doing altering table, set enable schema evolution equals to true. There you have to check the alter table. These 2 commands. Right? Correct? So external table with auto refresh plus, how does it work? With the help of a keyword called infer schema. Infer schema. How does it work internally? I will tell you. How does it work? So when you run a copy into file, right? First you will do all the external integration. You will set a stage. You will get the data from AWS S3, blah, blah, blah. You will create a file format, everything. Once you have done that, so when you run a copy into command, right? In order to get the data, which has the new column or which the column has been deleted, Snowflake will read the file header. First of all, Snowflake will read the file header where you need to write parse header equals to true. You need to parse that header. Okay, you need to parse that header. Either parse header equals to true or skip header equals to 1. Then it will build a list of incoming column with name and inferred data type based on file format plus first row scan. What does it mean? It means first of all you have to create a file format. First of all, you have to create a file format with type equals to CSV. And null if null, trim space true, encoding is UTF-8. So make sure you have an active database, active schema. I am in the demo database. I am in the demo schema. Just for the purpose I am using it. Warehouse I am using, is it the your demo warehouse? You see it here with the medium scale, and the role which I am using is the account admin. By the way, this is a new UI which Snowflake has come, workspace, which we call these days. It's a nice one. Okay, run this. Run this. So once we have created a file format, next what we have to create? Next you have to go to the AWS. First of all, there should be a bucket, right? Where you'll be having this data. Let me show you how the data looks so that you have a complete picture. Okay, let me show you the data. Just focus on the data sets. So the first data set which we have is customer1.csv. It has full-fledged schema. It has customer ID, credit card number, balance, purchase, installment purchase, cash advance, credit limit, payment, minimum payment, tenure, and date of transaction. So how many columns are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 columns are total there, right? Next, I will duplicate this tab. Next, what we have? Next, let's see customer data 2. Suppose the first week, client has sent customer data 1. Second week, client has sent the customer data 2. But see this. There is no column called tenure and date of transaction. There is no column called tenure and date of transaction. That has been removed. That means the second week, if the client is sending data and tenure and date of transaction was not there, what will be the value inside tenure and transaction for the second data set? Null will come into picture and your pipeline won't break. Third week, what that the third week client is sending the data? Let's see what the client is sending the data in the third week. Suppose the third week client is sending the data. This, it has tenure and date of transaction, but it does not have the minimum payment. It does not have the minimum payment. What also it does not have? It does not have installment purchase. Sorry, installment purchase is there. Customer ID, credit card number, purchase, installment purchase. Let's scan it. Cash advance, credit limit is not there. That means two things are missing: credit limit and minimum payment. See, column can get deleted from the beginning, from the end, and from the middle also. Anywhere it can be a schema change. That's what we call the structure. I am changing the table structure at all. These two columns are gone. Next one more. Let's see. The fourth week, the month end, client is sending you the another data sets, which is customer data sets 4. Oh my God. Here, what is this, Anand? Here, 4 more columns has been added. This column was already there in the first schema. Client has added age, city, country, and pin code. 4 more. All the 4 use cases I have sending you. The original schema, the deleted one from the end, the deleted one from somewhere at the between, and at the end, new columns have been appended. So what will happen to the old data? All these 4 columns will be created that will have the null values. That will have the null values. Now, the first question which you should ask, Anand, customer data 1, 2, 3, 4, I understood. But which is the main schema I have to take it? That question you should ask the data architect or the business consultant. You are showing me 4 data sets. That's fine. Which is the main schema? the table which I will be creating in order to consume this data, which you need not have to do it because Snowflake will create for automatically. On that, you have to select any one data sets which you want. I will select customer data 1. The default data set is customer data 1. This I am keeping it. This is my original schema. This I will keep as a reference. Right? This I will keep as a reference. So what I am doing, so first of all, these all data sets I have created a S3 bucket inside a folder called dev, and in that 4 data sets I have kept it. Customer data 1, customer data 2, customer data 3, customer data 4. Okay. All these 4 I have kept it. Right? All 4 this I have kept it. Let me delete this too as of now so that you'll understand it properly. I'll show you the real one, real magic, how things are happening in the IT industry, which no one else will show you. People are here, they will create a 15-20 minutes video and they'll be gone. That's not how the real case works. And now you have 1 data sets. Now, in order to access the data from the AWS S3, you need something called policy. You need something called policy. Now, this JSON file already has been given to you. This JSON file already has been given to you. This JSON file has been given to you. Here is the JSON file. What you need to do, I'll explain you. What you need to do, input your S3 bucket name with slash followed by star. Star denotes all the bucket and the subsequent folder. And here the bucket name. Kindly note this down. Okay. Here your bucket name. How you'll find the bucket name? Nothing. Just go back to your AWS S3 bucket. Right? Click on this. Go back to the properties. Just copy this. Okay. I'll go back to the objects. Dev. I'll go here, property. You see here. Right? Just copy this. Paste it here. Just copy and paste it here. Okay? ARN of your bucket. ARN of your bucket, which you are finding it over here. Right? Just bucket. Not the folder one. Just the bucket name. Just the bucket name in your policy. You just copy and paste it there. Okay? This is important. So you will create one policy. Right? JSON file. Go to the edit section. Copy my JSON. Already I have given to you. You do not have to apply any brain. Copy this JSON and paste it over there. Only thing you need to do is change your resource name, resource AR name. Right? Just this one. You need to change it here. So what does this policy do? This policy will tell what all necessary privilege has been given to that particular role. Right? I can put the object. I can put a file in S3. I can get the file in S3. I can delete the file in S3. Everything is there. Everything I can do it. Right? I can delete the object. So these are the set of instruction which has been defined in this policy. Just you need to copy and paste it. That's all. Once you have created this policy, what you need to do? You need to create a call role and you need to attach this policy. You need to create a role and you need to attach this policy. Lecture number 34 I have explained clearly. So I have created a role and I have attached that policy to it. Right. Now what you have to do in the Snowflake, you have to create a storage integration. What you need to provide, basically this is meant for integrating your Snowflake and AWS S3. So I will write create or replace storage integration. Name, this is an external stage. I am bringing the data from S3. Enabled equals to true for continuous integration. Storage AWS role ARN. The role which you have created, that ARN you will substitute it here. Here. Do you see this role? This ARN, just copy and paste it over there. And the S3 bucket name till your folder level. Till your folder level. My data resides in, where does my data reside? My data resides in dev, till dev folder. Right? Till dev folder. So I'll run this. Done. Then I will describe this. See this. Correct? Once you have described the storage integration, what you will get, I'll tell you. What you will get something called storage AWS IAM user ARN. This you need to copy, else you will get 504 error. This you need to copy and you need to go back to your policy and update the trust relationship. Go back to your trust relationship because here by default it will come root when you create a role. So go to a trust policy. Make sure you do it. Otherwise you will keep getting syntax error. right? And update this, right? Copy and update it here in AWS. Here by default it will come root. Okay, here if you go, you will see something like this, a number coming here. So you need to go here and update it. Make sure you do it and click on update policy. Else you will get 504 error, not able to access. Because this will check whether that necessary role has the right set of privilege in order to access this. What I'm copying it, I am user ARN, this one. Okay, this one. It will come like this. The fifth point number. This you need to copy it here. Once you have done this, then you need to define a stage. Right? You need to define a stage. So create or replace stage name, storage integration is this, URL is the S3 bucket, and the file format is the CSV format. You need to define it. Once you have done it, now you have established a successful connection with your AWS S3 bucket. Now what I'll do, I will see whether any file is there in the stage or not. Yes, file is there. Why, Anand? Why one file is there? Because in my Snowflake, in my AWS S3 bucket, I can see the first file over here. I can see the first file over here. Okay, I can see the first file over here. Right? I can see the first file over here. Right? So once we have done this, now the most hot favorite things come. How, Anand, you are creating a table? Now we are creating a table called customer data using template. Using template, what we are doing? We are doing select array aggregate. Select array aggregate. So whatever the data you are reading, it will create a JSON object. It will create an array in the JSON object format from that particular table, and you have infer schema. This is a hot favorite interview question. What is the beauty of infer schema? As the Snowflake says, same thing I'm going to read. It automatically detects the file metadata schema in a set of stage data files that contain semi-structured data and retrieve the column definition. Automatically will scan your data sets which is residing in AWS S3, and it will give you the schema. All the column data type. Nowhere I have created a table. This command I have not ran. Guys, I am not creating a table. Anywhere I'm not specifying the column name. Automatically this schema, infer schema is doing it. I will show you what the file it gives. Just have a look. I will run this. You'll see how the file it is creating. You see this? You see this? Copy. Let me open the notepad. I'll show you how it is creating. Okay. How this is creating. See this column name, customer ID, everything. See this. Are you seeing now? It is giving you a JSON file, column name. It has scanned it. Expression, textual data, file name, from which file it is coming. Nullable, is it nullable? Is it null or not? Order ID 012, and the type is the text. Everything it has detected in the form. See this number with nice precision also. That's the beauty of this infer schema. Infer schema automatically will detect the schema of your file. But the problem is, Anand, which schema it is detecting? Can I give here customer data 2? Can I give here customer data 3? Yes. It all depends on you. Whichever data schema you want to detect, the first file or the second, you can give that file name, right? Customer data 1 from the stage file, and it will infer schema automatically. Now I am creating this table. You see this. Now I am creating this table. Nowhere I have given any DDL command. Nowhere. Now if you see, if I describe this, automatically it has created. Nowhere I have given the column name, guys. I have not given a column name. With the help of infer schema, automatically it is detecting all my column, all my attributes, data type also it has detected. Everything it has detected. Right? Getting my point? Everything it has detected. Now once you have these data sets ready, what we will do? We have to set call alter table customer data set enable schema evolution, because now we have to enable schema evolution. Done. Once you have enabled the schema, now also you have to do alter file format, CSV format, set error on column count mismatch. Because of course, Anand, you are deleting a column, you are adding a column, there will be a column count match. So that you have to turn it to be false. I don't want error, because if you don't do these steps, you will keep getting error. Right? Run this. All I'm doing only once. Right? So this is done. Now, what I will do, I will directly go here, line number 85. This copy into command just for the testing purpose. Okay, just for the testing purpose. This is the automatic command which I'm explaining it to you. Create or replace pipe, customer data pipe, auto ingest equals to true. What is the beauty of auto ingest? Lecture number 34, lecture number 35. Automatically, whenever the new data comes, it will automatically ingest into your table. That too with schema evolution. Copy into customer data from the stage, file format, format name CSV format, match by column name. I kept on telling you, match by column name, case insensitive. It may happen, right? Suppose there is a column called first name. Suppose there is column called first name. It may happen that you are writing first name like this. Few people are writing first name like this. So these both are same only. That's why match by column name I am matching. Case insensitive I am making it, so that if these two columns are there, it should not be treated as different. Both are same only. Getting my point? So this is very, very important for you to understand. Okay. This is very, very important for you to understand. Next. On error equals to continue. Right? On error, you have to continue. Run this. And now you see the magic. Let's check whether any data set is there or not. Yes, first data is there. It has been sent. Let's check the count. So every data sets, by the way, it has 1,000 records. Now it has not come. Let's wait for some time. Game. Bang on. First record came. 1,000. Okay. Let's see the data. Right? All the columns are there. Now let's go back to the second data set. What was there in the second data set? Second data set, last two column was missing. There was no tenure, there was no date of transaction. Let's insert that. Let's do that. I won't run any code. I will just upload. I am the client now. I am uploading the code. Automatically it will take. Automatically it will work. It will ingest it. You will see the magic. Let's upload it. Because auto ingest equals to true is there. Let's check the pipe. Let's check the pipe. This pipe I'm running just to show it to you. Yeah, it has been sent. Now what is the count? Every these data sets, customer 1, 2, 3, 4 has 1,000 records. So now the count should come 2,000. There should not be any error. Right? And then I'll show you the data. Let's wait for some time. Now, depending upon the data sets, how big or small the data sets, it takes time. 2,000. There's no error. There is no error. Let's see the data. Let's see the data. Now the real magic will come. Those two columns were not there. Where those data got inserted? Ah, here it is. Here it is. Here it is. See the magic. These two columns were not present in that data set. Null, 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 null has come. Okay, there's no error. Your pipeline has not failed. I did not run a single line of code. Automatically, let's ingest datasets 3. Let's ingest datasets 3. This is how things are done in the industry. So learn the right way and explain in interview. You won't find such video ever on YouTube in that particular detail. Everyone has taught blah blah, only one use case they have covered. I'm giving you the complete use case. Let's see the third data set. What was the third data set, guys? Third data set has some columns removed from between. It was not having credit limit and it was not having what? It was not having the cash advance. Sorry, cash advance is there, credit limit and what was not there? Payment, cash advance and then credit limit. Ha. Credit limit. That was not there. So I've ingested that. Done. How many data sets I have now? 3 data sets has gone. Let's go back. Let's check the pipe. Third data set had been sent. Now let's check the count. 2000. Let's wait for some time. If the data set is very huge, guys, sometimes even it takes 2-3 minutes. 5 minutes also it has taken. So have patience. Okay. Have some patience. 3000. Now if you want to see what all data have been pushed in the last 1 hour and whether the counts are proper or not, you can run this last piece of code. See this. Right? Row count and row part. This is for the data validation. You can check it. Right? 3000 records. Let's again check it. No error in the code. I'm not running any piece of code. Just I'm showing you select star. That's it. Let's run select star and see. Ah, balance is come. Balance was not there. Credit limit was not there. Null, null. Null, 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 null. See this. See this. There's no error. That's the beauty of the schema evolution. The last case. Last case, new columns, Anand, you have added. Last case. What was the last case? I have added the 4 new columns. Let's add that. Let's add that. See the magic. Aram say relax your Sunday night. Let the client do the work. Let them send the file. Let your Power BI get automated, updated automatically. You do not have to do this. So this is how the schema evolution comes into picture. Let me upload this. Now what will happen? 4 new columns I have added. So the first 3 files, all the values will come null over there. Right? All the values will come null over there. Let's go back here. Let's check. Still it has not come. Let's wait for some time. Have some patience. 10 seconds, 20 seconds. Sometimes even a minute it might take. Okay. Let's check the count. Still 3000. Let's wait for some time. Did it got the data set got uploaded? Yes, no, yes, it got uploaded. Let's check why it is taking this much time. Sometimes it do take. So have patience. Let's check the pipe, whether the data set has gone or not. This alter pipe data refresh is only for you. Yeah, it has been sent. Come on. It's taking time because the new columns has been added. So it is reading the schema and then accordingly it is updating. So everyone try this and add it in your resume. Okay. Everyone try this and add it in your resume. Come on. Yeah, it came. See this. Bang on. 4000. Sometimes I told you it might take 1 minute also. So that's the beauty of this Analytics with Anand channel. Everything I teach you live here. There's no recording over here. Right. Now you see. It has been passed. Right. 1000. So all the 4 data got loaded. Let's see now. Select star. Right. Let's see. Oh, you see this? 4 column got created. You see this? Few has the data sets because the latest file has data sets and the previous data, what it has happened? It has inserted null. It has inserted null. Total 4000 records. Right? Total 4000 records. That's the beauty of the entire schema evolution. Let's describe the structure now. You will say, what has happened to the table structure? It has added because schema has evolved. So structure will of course change. If you change the table definition, if you check it here, see this. See this. Nowhere I have written create table, guys. Automatically this has created for you. Automatically it has created for you. So the last file. So the schema final will be decided by hot favorite interview question. Schema of this final table will be decided by the last file. last ingested file, provided there is a new column addition. Provided there is a new column addition. If there is no column, new column addition, last to last. Okay, last to last. So keep this thing in mind. Last to last. So this is all about schema evolution. Now let's understand some more part. What some more part? This is what I have told you. Right? So how does it work? Internally, this is very, very important. So when you run copy into command, Snowflake reads the file header row, right? And then it reads the first row and identify the data type. All this information is stored in informational schema.columns. Snowflake queries the table catalog metadata using informational schema.column. Everything is stored here. If you go here, informational schema, you see here, entire information will be stored here. If you go here, columns, you see here, right? Everything will be stored here, right? Entire your table catalog, everything is stored here. Everything is stored here, right? If I do, see this. See this. You are seeing? All the information is stored here. Customer data, every information is stored here. Every information is stored here. All the columns, which column we are pulling it, right? Table type, table transient, last altered, last DDL, all the information are getting stored here. Informational schema column. Getting my point? All are stored here, right? So they might ask you in an interview. They might ask you in the interview, right? How does it work internally? So it does a case insensitive match. If you use match by column name, missing column present in file but not in table are identified. Extra table columns not in file are left as it is. Those columns will get null in new rows, right? So how does it work internally? Right? So internally, for each missing column, Snowflake generates an internal alter table command, add command, add column command in metadata. Now we all know Snowflake works on the principle of metadata, right? It keeps a scan. So new columns are added as text or varchar by default, unless schema inference can safely decide. Column order does not matter. Hot favorite interview question. Will column order will matter? No. Column order will not matter since mapping is only by name. Right? Since mapping is only by name. Right? So once schema is aligned, Snowflake runs the actual copy into load. Column to column mapping happens by name, not by position. Remember this. By name, not by position. Values are cast to the table data type wherever possible with try-cast semantics. If conversion fails and on error equals to continue, bad rows are skipped. Otherwise, load about. That's why we gave on error equals to continue. What happens when columns are removed in the file? Snowflake does not drop column automatically. Rather, those target columns just get null values for new rows. Right? So you must manage clean them yourself. Now, if you don't want null, if you want some values, that you can do clean up later. Right? Correct? So this is what I have explained you in the entire schema evolution. Please go through it. Please go through it. Right? Now the most important one. All the code, everything I have given to you. This I have explained you the demo also. Now, I have one question. How does it? Right? What will be the impact on micro partition? What if the interviewer asks you? Nobody will teach you these things. What is the impact on micro partition? What is the impact on cost? So the first one, if we understand, right? What does micro partitions are? So whatever data you store, Snowflake creates a copy of data, 3 files, 3 copy, immutable micro partition. You cannot change the micro partition. Even if you delete it, new micro partition gets created. So 60 MB each, right? And it contains columnar data in compressed format. And what does the metadata it has? It has minimum, maximum values, null, count, and all those things, right? This is how the Snowflake has been designed. Now, what happens when schema evolution? Now, when you run schema evolution, alter table set enable schema evolution equals to true. Snowflake does not rewrite old micro partition. Rather, it will only update the table metadata. This will ask, they will definitely ask you in interview. Do you know how internally schema evolution works? This is what you need to explain. What happens at the micro partition level? Right, see, schema revolution everyone will teach, but they will vanish. They won't teach you that much of use case. What happens internally to micro partition? That's why I tell you, this document is a one shot. You don't have to refer ChatGPT or any resource. I have just created. So what happens? Snowflake does not rewrite old micro partition. It updates the table metadata. It adds a new column definition. Default type is varchar, and old micro partitions simply don't have this column. Internally, when a query asks for that column in old partition, Snowflake injects nulls on the fly since older partition did not store values. Remember the first case, customer data one was not having those newly added column, right? Correct. So what did Snowflake does? Snowflake went to the old micro partition. Those columns were not present. Now you are doing the schema evolution. You will simply ingest the null values into that. Right. Now what will happen? Since the new columns has been added, new micro partition will be created after the schema change. Will store the actual data. Right. For example, in our case, when we loaded the customer1.csv, 10 columns, partition contained 10 fields. When we loaded the second CSV, suppose we are adding an age, new partition contain 11 fields. Now query is the select age from customer data. Now age is, when you added age, new micro partition get created. So the old partition will return null and new partition will return the values. Schema evolution does not rewrite old data. It's a cost saving. I'm coming to the last part of this. Will it impact the cost? So schema evolution does not rewrite old data but makes queries return consistent result. Right? What will happen when columns are missing in a new file? Suppose your table has 12 columns we are seeing. Snowflake will just create new partition where missing columns are filled as null in partition metadata. So partition stays consistent, no error. How will be the query performance impact? Now, because schema evolution is creating a wide tables with varying column sets across partition, if you query new column, Snowflake may need to scan only the newer partition. Good for partition pruning. Good for partition pruning. If your query contains old plus new columns together, right? Which use case? The fourth use case, customer data 4, evolved one. You had the old one also, and then you had the new one also. So if your query contains old plus new columns together, Snowflake will scan both sets of partition, injecting nulls where needed. Metadata overhead slightly grows since Snowflake must track column presence across partition. So as you keep on adding the new columns, new micro partition will get created, and Snowflake has to scan all this newly micro partition. So there might be an overhead. That's what it says, right? So does schema evolution fragment partition? No, partition remain intact and immutable. Adding column just means new partition have a slightly different schema evolution version. Internally, Snowflake will still use the metadata to reconcile this difference. For example, say for your P1, the partition scanned is P1, which has customer ID, balance, purchase, and date of transaction. Now you added a second column, age. Again, the new micro partition will get created. Again, this P1 has 3 replica. That's how time travel and zero copy cloning works. Again, this P2 have the new replica. Oh, sorry, my bad. Again, this P2, since you have added age, again new micro partition will get created. You have removed few columns. Again, one new micro partition will get created. Now, when you will query, Snowflake's align partition at runtime, so you always see a flat table. Internally does. Right? Now, since Snowflake aligns columns by metadata, what will be an impact on clustering and pruning? So pruning means, what is the literal meaning of pruning? Skipping the partition. Now, query is highly efficient when it is scanning minimum number of partition. If the partition scanned is more, your query is not efficient. So here, partition pruning, skipping will still work for old columns. For newly added columns, pruning only applies to new partition. Right? Old ones don't have min-max statistics since values are null. So if your query rely heavily on new columns, pruning efficiency increases only as more data where those column arise, because Snowflake just have to scan new micro partitions. Getting my point? All the use case after this document, not a single question interviewer will ask to you. So don't worry. Everything I have given to you. Everything I have given to you. What is the cost implication? Right? So whenever you are creating a new column or you are removing unique column, costs are not associated with the schema. Only when the data you add in that column, then the cost comes into picture. Right? Now, query cost may rise slightly because Snowflake must merge metadata from partition with different schema. It may happen if you need the old data, if you need the new data, Snowflake may scan old micro partition, new micro partition, then query cost slightly will vary. Right? So with wide evolving tables, scanning extra column increases cost if analyst uses select star. That's why what does the thumb rule of while working in the data analytics, you should always avoid select star. You should always avoid select star. So schema evolution in Snowflake is metadata driven, not data rewrite. Old micro partitions stay intact, missing columns are null filled, new columns appear in new partitions going forward, query performance impact is minimal unless the table grows very wide, pruning works as usual, but for new columns, it only applies from the moment they are introduced. The last part, we have come to the last part. As I promised you, 1 hour session, I will keep you entire information, code, everything I've given you. If you would have tried on your own, this entire would have taken you 1 or 2 days. Lot of syntax error, you will get a lot of runtime error. Now, in my code, you won't get any error at all if you have designed role and policies properly. Right? So every time Snowflake add new columns automatically is just a metadata update. You are just updating a metadata. There is no cost factor associated with it. Adding a column itself is free. DDL does not cost storage. If you're creating a table, it does not cost you until unless there is a data in that. Storage cost only come when you load data into those new columns. So if the data is not there, if it is null, it does not have. So example, if a new city has been added, if you added age, but all the rows have null, almost no extra storage. Since Snowflake stores data in a very compressed, sparse format. That's why storage costs grow only when the actual data volume, not with the respect to schema changes. Right? Schema evolution can influence compute usage in 2 ways. Extra check during copy into. Now, when schema evolution is available, Snowflake must compare incoming file headers with table schema. This is a metadata lookup. Negligible additional compute, hardly some cents it will cost you. Alter table, add column. This is automatic. With Snowflake does it for you at the backend. Internally, Snowflake uses an alter table for new column. This is metadata only. Again, it's a metadata. Does not rewrite data. So almost zero compute. That means overall, if we talk about the cost, until unless there's a new data coming into that particular column, Snowflake does not charge you for that. Copy might take a few extra milliseconds, but cost difference is very, very negligible compared to normal load. Now, we all know, since we have implemented the concept of Snowpipe, and Snowflake charge you for Snowpipe for per file. In our case study, we have ingested 4 files. So Snowflake will charge me for that, not for the column creation. So you already pay. We already pay for Snowpipe ingestion charges per file, per row inserted. So 4,000 records. So Snowflake will charge me based on that. 4 files, total 4,000 records. So schema evolution does not add extra ingestion charges. It's just part of the same copy step. The only cost if you build audit log. Say, for example, I am building an audit log, which you will see in the part 2 soon. And again, entire this pipeline I will design in Matillion that you will see in part 3. Right? What if I am creating an audit log where which tables has been inserted, which column has been appended, which column I have dropped it, what all schema I have added it, which columns I have added or removed. For that, audit logs you can create it in order to monitor schema changes. Impact, no extra Snowpipe cost beyond normal ingestion. Downstream query cost, if schema evolution makes your table very wide, say 200 plus columns, that's what my thumbnail says. Query that uses select star will now scan more columns. Always avoid select star. Even if many are unused, this increases compute cost for BY query since Snowflake scans more micro partitions. Okay. Higher query cost if your analysts rely heavily on select star. So what will happen to the maintenance cost people over time? Dev team must manually alter table, fix pipelines, and rerun loads without schema evolution. That means more human hours, indirect cost. But with schema evolution, fewer pipeline breaks, reduced engineering effects, and huge cost savings on maintenance in the long run. So overall impact, if I talk about the overall picture of this entire 1 hour session, direct Snowflake cost, storage plus compute, negligible. Snowpipe ingestion cost remains unchanged. And biggest saving is the less manual work, faster pipeline, and fewer changes. This is what the last example I have said. A retail company loads 10 GB per day of CSV. Right? With schema evolution, new column added as varchar, tiny metadata cost, extra storage only for new column values, saves 0.5 GB per day, query cost grows if analysts keep doing select star. Always avoid doing select star. So the incremental Snowflake bill change is tiny compared to the operational saving. Right? This is what all about the schema evolution. So this is the checklist which I have given. Match by column name or error request to continue. Just go through it and read it. Right? Discourage select star. Use views for stability. Right? Create a view. Go with the materialized view. Right? If any new derived columns are coming like full name equals to first concatenation with last are heavily used, materialize them. Avoids repeated compute. All this best practice I have given you. You can track all the schema evolution with a log table. That I will also show you. You can create a log table which will have a log file name, added columns, what columns you have added, from which file it has inserted, when it was inserted, who inserted it, what column we have dropped. Right? That way we can monitor all these things. Right? How many rows has been ingested? Informational schema.copy history to monitor number of rows ingested, which I have shown you here. Right? I have shown you here. Yeah. I've shown you copy history. Very good command, hot favorite command, which we'll ask in an interview. I usually sometimes ask, which was the file name, from where it came, when was the last time loaded, how many rows gone, how many passed, right? What was the file size, everything, which database, which pipeline, which schema, when it was received, bytes built, this many bytes have built, right? These all information is my informational schema dot history. Everything is this, right? Correct? Small warehouses. Usually, if you have a very small warehouse, if you have a very small data set, you can use small warehouse. Right? Micro batch. If you get tons of tiny files, consider batching them before Snowpipe, combine, and then you use. Use variant for highly dynamic schema, liability, logs. I have taught you already, lecture number 39, variant data type. Right? Everything I have covered in this lecture of schema evolution. Hope you have liked it. I have covered all the use case, everything. Just practice this anywhere. If you are having any doubt, feel free to reach out to me. I'm there, happy to help you. Right? This was the lecture number 46. So far, 46 videos we have covered in the YouTube. That's all from my side. Thank you. Bye-bye. Good night. Take care. And do subscribe to Analytics Channel. Let the data do the talking. And if you've still not enrolled into the job guarantee program of data analytics, go ahead and join this course and change the future of yours. This will really, really help you in future. Trust my words. Right? You're not talking to any salesperson over here. You're talking to a highly intellectual, educated person. Okay? Right? So venture into the data analytics if you belong from any field. This is the era. You need to learn Gen AI. You need to learn all those things. After data analytics, data engineering, data scientist, AI, ML engineer, Gen AI, LLM, lot of things are there to do. But only things you have to keep in mind, if you are jumping into this ocean, you have to study every single day. You have to study every single day. That's the only biggest cons. So if you are not someone who is not a hard worker, then don't go ahead for this. Then you rely on 40, 50,000 salary, whatever you want. But if you need a much higher salary, bigger salary number, then data analytics is a field which you should opt for if you belong from a non-technical background or any background, I would say. Okay, that's all. I'm signing off for now. Bye-bye. Take care. Do subscribe to this channel and